Alright, welcome to Goon User Groups Episode 2, Optimizing VMware. I'm reshooting this just because I had some computer issues with Windows 8, specifically upgrading from 8 to 1. Movie Maker decided to corrupt a few things, so I'm going to be reshooting this. And, well, frankly, I had a cold last time I did it, so there was a lot of blank, empty space ongoing. What is he doing? But basically, I'm Dilbert. If a lot of you don't know me from the forums, I am a VMware guru of sorts, and I'm a VMware fanboy to many extents. Tonight, I'm just going to be talking about VMware, basically things you can optimize in your VMware environment, both lab and production. So if you're looking either for just memory tweaks or CPU or storage, I'm going to be covering all those topics. And I'm sorry if I sound a little off. I'm still getting over a pretty nasty cold, so apologies in advance if I just sound a little weird. No Sudafed this time, because that was what made me drowsy last time. Alright, to start off, the topics I'm going to be covering are ESXi host configurations. I'm going to go into memory, CPU, network, and storage. There are a few other things that you can do with hosts, but what I'm looking for is it doesn't cost my company any money, it doesn't cost my lab any money, just things you can already do with your VMware environment that you can't really do, that you can do without purchasing anything. Sorry, I screwed up there. And then I'm going to go on to virtual machine configurations of optimizations with those VMs. Basically, I'm just going to run through the ESXi hypervisor, some vCenter settings, and whatnot as well. So first of all, there are a few configurations you can do in ESXi that make your life easier. The first one is power options. A lot of people don't set this, but I'll show you how to set it. Most of the time, the default is fine. It's going to be under Configuration, Power Management. Now, there are probably going to be three options that most of you guys are going to use. They're going to be high performance, balanced, and low power. If you're running servers, or if it's a standalone server and you're only running like an Active Directory server and whatnot, you may choose low power, because what happens in low power is it starts stepping the CPU down and only clocks it up when absolutely necessary. Balanced, it kind of has a smart configuration in there. It keeps it a little higher, but along the same lines. And high performance just does not lower any power usage and keeps the CPU and other resources running at full. Now, if you're doing something front-end web, you may want to make sure all your hosts are high performance, because you can't always expect what the performance impact or what the requests your hosts are going to get. Oh, yes, thank you, Windows 7. No, I don't want to improve performance. It's fine as is. Sorry about that. You can use high performance in an unpredictable environment. A lot of people leave it as balanced, but if you're dealing with something ultra high performance, such as front-end web servers, so you have an ESXi cluster that's full of web servers that are just front-facing. That's all they do all day. High performance is good. Same with SQL. Anything that's completely unpredictable, you can't always wait for the CPU to clock up, even though it's in milliseconds that it takes the CPU to clock up. You don't want any of that. Balanced, generally good for most environments. I can't really say I've seen too many people change this. Usually I put high performance on all my hosts if I'm doing VDI or something that's front facing that I can't say this is going to be the average traffic. I don't want to change it. There. Okay. Balanced, if I'm just doing some server virtualization for a 9 to 5 organization, balance is okay, depending on how busy the environment can be, but most of the time balance is your all-around best player. Low power, I don't really see anybody use this, but if you needed to, say the HVAC went out in a server environment and you wanted to make sure that whenever the host was not busy, it was using as least power as possible for its resources, you could use low power, and that would avoid turning off hosts. But really, if HVAC is out, you should probably have bigger problems. I leave mine usually at balanced. I did it at high performance because I was having some slowness issues with one of my VMs. But I'm going to change that back to balanced. And of course, you can do this real time. It doesn't really affect anything, just like in Windows 7. If you go to power, you can actually change the power settings. It's very similar. There's also a custom option that I didn't really get into, but I have yet to see anybody set a custom user-defined power policy. If somebody knows of it, respond to this video. Love to hear it. But yeah, that's basically power. Just realize that it does some things with the CPU stepping. That means, say you get a 2.4 gigahertz processor and it has Intel Smart Step, or I forget what AMD calls it. Either way, what happens is if the CPU isn't fully loaded, it will start clocking back the gigahertz to save power, which is, smart, right? Nobody wants to have unused power. The problem is when you have unexpected performance spikes, the CPU has to play catch up. So to some environments, that's not good. They need it running at full flag all the time. And I actually believe that high performance is a requirement if you're doing something like fault tolerance. And I think fault tolerance is really going to go a long way in the future. Right now, not a lot of people use it, but I think it has a really good potential. Whoops. Okay. Read cache options for VMs. This is kind of more of a 5.5 setting. Basically what you can do is if you have SSDs in your server, you can specify a read cache, meaning that the VMs, when they go to your storage, whatever that might be, I believe it's, well, I think it's pretty much all storage right now. It's going to see the hot blocks or data that VM is reading off the data store. And what you can do is say, okay, I'm going to cache, 512 meg or some number of blocks in this flash drive or virtual flash drive, and it's going to be residing in an SSD cache. So instead of going for the data store for all data, it's going to say, oh, that hot block or hot piece of data is sitting right in my SSD cache. So what I'm going to do is grab it out of the cache instead of going to my array or data store. So if you have an older array, but you can get SSDs in your server, that's a really great way to save a lot of money in your budget. But that is, like I said, only an ESXi 5.5 feature. And I believe it's only enabled, you can only enable it from the web client, but the web client's not that terrible in 5.5. I didn't see it as bad. Resource pools. A lot of people use this for VM management, like in my lab. I actually have a resource pool called management. Now, I made this just for show, but a lot of people use resource pools to go, oh, I'm going to manage my environment, make resource pools. It keeps all my VMs nice. Yes, it does, but that doesn't mean that's their intended purpose. VM pools are meant, or resource pools, I'm sorry, are meant for carving out resources. If you're in a constrained environment, there's not too much else to say. Like, I open up settings, okay? Let's say work in a CPU constrained environment, and this management cluster is super important. So I can go in here and start carving out, who gets to talk more to the CPU versus just letting everybody fend for themselves. Or if I'm in a RAM constrained environment, who gets more shares of RAM than the other. These are not for management, and you can really, really screw stuff up if you don't know what you're doing. Because, as we all know, if somebody comes in here and goes, oh, I need shares to be high on this, and then they go, oh, on this cluster here, I need shares to be high as well. Well, you're just starting to screw stuff up. Unless you're running into contention, try not to use resource pools. This doesn't mean that some things like vCloud Director or VMware View are going to want resource pools. They're using it in a bit different manner, but realize that resource pools are for what they stand for, a pool of resources that you can kind of control. So if I wanted to, and I set this, if I uncheck this limit of RAM and I limited it to something like, let's say, 2 gig. If my pool, which I know is over 2 gig, it's going to force stuff to swap, and it can actually hurt my performance a lot. Same with reservations. If I reserve too much memory, then other VMs that are not in that pool may start to have performance issues. And this can be a real troublesome because a lot of people will go, oh, VMware, I can oversubscribe things, or, this isn't necessarily specific to VMware. There are other things, other hypervisors that have things similar, but the concept is for VMware, don't use resource pools for management, especially when somebody goes, oh, reservations, I need to reserve as much memory as I can. And then you run your host out of memory. Not a good day. Performance suffers. Don't do it. Especially with CPU. CPU is precious. There are a lot of ways to get RAM back, not a lot of ways to get CPU back. I'm going to go over that in a bit. Okay. If you're going to do VM management, let's say you have a 3-host cluster, Essentials is $500, like $550 maybe. It's probably one of the better things you can buy, and I'm not just endorsing that because, VMware's paying me. They're not. It's a really, really good feature, or really good bargain for that matter. It allows you to do so much stuff, but if you're going to do management in a production environment, use VMware folders, or VM folders. And I'll show you that right now, and I'll tell you why they're good. A lot of people will just set up a host and just leave their VMs there. And I'm sure a whole bunch of people watching this video have just logged into an ESXi host as root. Well, you got to realize root, if you're not familiar with Unix, basically allows you to change anything in the system. It is the super user, the admin of the machine. You can do a lot of bad things with root. You can also do a lot of great things with root, but with great power comes great responsibility. So, in order to help manage this, we have what are called roles and folders. Nope, I don't want to go there. So to get our folders, we're just going to go to VM templates. Now, a lot of people just leave discovered virtual machines and put everything in it. Don't. Creating folders are not hard. You right-click on your data center, new folder, and then you choose the name. So I'm just going to say Goon folder. Okay, so now we have our Goon folder, and let's say I have some goons that, I can't be bothered at 2 a.m. because somebody is calling the help desk and saying a server's down, or, I have an assistant who is really good with computers, who's monitoring some of these servers. So I'm just going to say, okay, you know what, this Windows server I have, I need it to go into Goon folder because I don't want to get every single email in my inbox about I can't contact the server or is the server down. So what I can do here is I can actually right-click on it, add permission, and because my host is on Active Directory, I can actually search my domain for either users or groups. And, you know, this assistant who's really, really good with computers, but not terribly good, I can say, okay, I'm going to add him. But, you know, I don't want him going and resetting anything. I want him to come to me if there's an issue. So I may give him read-only to this folder, and that's it. So he can log into my VMware environment and only read this folder. So I think I can actually test that for you. So I'm going to basically give this Goon read-only privileges to anything in this folder. And as you can see, it's going to propagate to child objects. And since I put my Windows server in there, it's going to give him read-only. So there we go. Looks like it completed. And let's go into our domain. That was Goon 2, right? Hope so. Sorry, I'm re-recording this and nobody's watching, so I'm talking to myself here a lot. And I didn't guess this password right. So let me go into my domain controller real quick and reset that Goon's password. Yes, I know I didn't guess it right. There we go. And I just kind of want to show you guys this because I know a lot of IT administrators, they manage their VMware environment to an extent, but you know, nobody knows everything, and I realize that. That's why I made this Goon user group, because I want people to share ideas. So when I get in here, sorry, I'm still a bit under the weather here. Okay, so we go to Find, and let's look for our buddy, Goon 2. There he is. Alright, so we're going to use our super secret password of password here. Hopefully nobody ever guesses it. And we're going to actually try to log back into our vCenter server. That actually might be the problem. Sorry, it's kind of late. It's like 12 o'clock. I just need to reshoot this because a lot of people are asking for it. Nope, it is Goons. Wow. There we go. Okay. So now I didn't do it all the way, so he doesn't really have a lot in here. But as you can see, all he has is he can tell that, you know, the state is powered on. VMware Tools is reporting normal. There are no real error. Well, this reports more in VMware Tools, but there's a lot. It's reporting in okay. I can see that, you know, it's not really reporting the host right now. I may have to tune in a little bit more. I can see that it's definitely not out of disk space. CPU appears to be fine. Host memory, you know, it's not really maxed out of memory. And he still has the option to add in these other tiles just by right-clicking up here in this pane. So I could say, oh yeah, this is the domain controller. It's reporting up. Everything looks to be fine. No alarms are enabled. So that may save me a call and just let somebody else take care of it. Yes, it is up. And that's kind of what I want to show you. Limit permission, adding to the domain is not a hard task. Once you have your, if it loads, okay, there we go. Once you have your DNS and routing set up properly, you're pointing to something that can resolve your domain, and you have a valid domain name. A lot of people get hung up and we'll just leave this local host. Yeah, you got to change it or else it won't join the domain. And then you just come down here to authentication services. Super easy. You just select from here. You say domain, type the domain, and then this leave domain option would actually be a credentials plugin. And you just put in any credentials that can join computers to the domain. And if you need to create roles, custom roles, fully supported, you come into this home button, roles, right-click on this left pane, add, and we can just make new role. And all I want this guy to do, this is my help desk, I just want them to be able to acknowledge alarms, create alarms, and modify alarms. So if anything comes in alarm-wise, they have to watch these alarms and they have to get in contact with me. I don't want them doing anything else. I don't want them configuring hosts. I don't want them doing anything. I just want them seeing alarms. Then I can do that. All right. Use AD for ESXi hosts. I can't stress this enough. Make sure a lot of people will just set it up, use root, and they'll be done with it. The problem comes in where people go, oh, I'm going to set it up with root, and then they start giving out the root password to people. People make changes or whatnot. Or what's worse is somebody sets it up with root, they don't join it to the domain, and finally they just leave the company, or they need to upgrade the host, they can't remember what the root password is, or well, you don't really need to. I think you can actually fool ESXi and upgrade ESX without the root password, but you can't back it up. Yeah, that's it. So there's some issues that come into play if you're just using root for everything. Use AD, carve out your privileges. It's best for you, your company, everybody. There's some environments where people don't want to use AD. They say, oh, well, I don't want my ESXi host to get compromised. Well, I'd be willing to bet that chances are your Windows host will get compromised before an ESXi host. Not saying it's impossible, but unlikely. Especially if you design your environment right, which you should. The next one is ensure BIOS and firmware updates are kept up with. I cannot stress this enough. BIOS updates and firmware updates are going to solve a lot of your little weird, funky things, and with virtualization, there's no reason you can't do these. vMotion, you can vMotion all of the virtual machines off a host lively. Take the host down, update everything, and roll. BIOS and firmware updates can provide significant performance improvements. I've seen where they've provided somewhere up to 10 to 15% on UCS servers just by updating the BIOS. It's awesome. If you've ever updated drivers on your computer, think of it like you wouldn't let your if you're a gamer, you wouldn't let your graphics card driver run out of date and just be like, you know what, it's fine. No, you try to keep it up to date, keep the most performance. Do that for your company or whoever, even if it's a lab. BIOS updates are your friend. Some people go, oh, well, I don't know what BIOS works for me. Well, ESXi tells you. You can do this live. So, if you're using a standalone host, it's going to be a little different, but with vCenter, it pulls some cool information. So I go to the hardware status tab, and it's going to tell me the BIOS, the manufacturer. So it's American Megatrends Incorporated and BIOS version 3. It will tell me the model of the motherboard, the serial number, everything I need to know. It'll also give me some cool information about how the CPU is performing. This can be in non-Supermicro motherboards and some other things. You can start to see a lot more information here, like actual temperatures of CPU, cache utilization to some extent. I don't know where my plus arrows went. Oh, they disappeared. Okay. You can also come down here and see, okay, I have a capacity of 8 gig in my memory DIMM 1 slot and the speed. And you can do that for as many as you want. Really cool stuff. You can even come here, see your PCI. It's really helpful if boss asks you, hey, what kind of card we got? And you got vCenter, hardware status is your friend. You can also get system alerts. I don't really have anything. But most importantly, you can get your BIOS information. So I'm going to just take the model of my motherboard. That is definitely not it. Copy. And it didn't copy. H8 SGO. And I know it's -F. I looked it up before this recording. Yep, that's my motherboard. So if you had a like a Dell or something, you could use a service tag and then do a smart lookup, which I probably recommend if you have a enterprise grade system. But Supermicro is nice and easy. Update your BIOS. And no, ESXi is not going to tell you if your BIOS is out of date. You have to look this up. To my knowledge, I know there's some cool stuff you can do with Cisco UCS where it will actually tell you, hey, your BIOS is out of date. I know HP does it and Dell does it with a third-party plugin to vCenter. But all right, so as we can see, I have version 3, and the latest is version 3A. So I know it's out of date. I could update this if need be. I'm not going to because I don't want to take my lab down because I'm doing this WebEx. As far as firmware goes, same thing. Keep it up to date. But read the release notes before you update. And I can't stress that enough. Read release notes on BIOS updates. Make sure, hey, the BIOS I'm getting doesn't cause any issues with VMware. It's a 5-second look. TPS and memory considerations. A lot of people grossly overestimate their RAM and memory that they need for their system. This isn't necessarily a bad thing. Hold on. But realize there are a lot of ways to save memory, and there are a lot of ways to optimize your virtual machines for the memory you have. I'm going to get into that a lot later. TPS can do some really great things for your environment. CPU shares and total number of CPUs that a VM should have. I'm going to get that into a later slide. Just bear with me. Storage, VAI, getting that to a little later, and networking. There's some cool stuff you can do with networking that a lot of people don't know about. So, what is TPS? TPS stands for Transparent Page Sharing. This means If you know how deduplication works, imagine it doing it in RAM. And if you don't know how deduplication works, basically if you have a memory segment that is A, and another memory segment for another virtual machine that is A, well, you have two identical pages in memory. So if they're both identical and they're shared between two virtual machines, why do you have to have both of them existing? So what TPS does is basically it will say, oh, okay, I have two pages that are exactly the same. I'll have one and then just put pointers. And people go, oh, well, what happens if my virtual machine has a virus? Well, it's read-only in memory. So the virus would have to exist on both virtual machines for it to run on both virtual machines. It operates below the VM level, or below the OS level. If you have SV host running in 5 Windows machines, then in RAM, VMware can see that and say, okay, well, all these svhost.exes are using the exact same signature. I'm just going to have one memory page and then just use pointers for the rest. Saves you a lot of RAM. Yeah. Ugh. Hold on, let me take a drink. Sorry, your throat gets really dried out during these. So basically what it can do is start saving your host memory. And that's really helpful, especially in older environments where, well, not even older environments, any environment really, where management comes down and says, okay, we put down blah for this much money, and we want to expand. You know, of course they're not going to say we're at fault for not telling you we wanted to expand, but they want to expand anyway. TPS can really help this, especially with running like operating systems. Like if you run a whole Windows environment, and that's all you run, TPS can help a lot because a lot of what Windows runs is probably going to be common, especially if it's just like a whole bunch of Active Directory servers. You can really get some gains in there. But as a standard, at TPS, a lot of people will go to 5.0 and say, oh, I'm not really getting the TPS I need. Well, for that, there are a few caveats to TPS, and a lot of people scratch their head to what I'm about to say and say, why did VMware do this, or why did any hypervisor do this? Well, I think I know the answer, so just listen to what I have to say. There's something called extended page tables and large page tables. Basically, these operate at a 2 and 4 meg block size. Now, what this allows is programs to claim pages of 2 and 4 meg. Now, that's really great if you have a dynamic program, such as a Java application, that may balloon instantly for any reason. Not that it would be bad coding, but, you know, it can inflate maybe 600 megabytes. Well, for a CPU to go, okay, I got to schedule 4K, 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 you know, that's a lot of work. But doing 2 or 4 meg sizes is a lot less work, and it's faster. So it allows programs to perform better that are memory intensive. And in 5.0, they said, okay, ESXi is going to support and it's going to have enablement of large page tables by default. Well, that's great and all, because it does help virtual machines that support it. I think it's pretty much anything 2008 and higher, Windows Vista and higher on Windows, and I really don't know on Linux. I think it's something like 6.0 and higher, but you can fact check me on that. I don't really know about Linux or BSD. But it's going to help those operating systems, and it's going to help reduce CPU overhead. But Since TPS works at 4 kilobytes a page size, it kind of breaks it. It doesn't turn it off. It just kind of reduces how effective it is. So people, when they upgrade, they go, oh, my hosts are running higher memory. And, running higher memory is not a bad thing if your virtual machines are tuned to the proper amount of memory. The problem comes in is where people start freaking out, but I'll get into, I don't want to get too much off track, but basically TPS isn't going to kick in until like 94 or 92%, or the host is oversubscribed in memory, where VMware has to start saying, okay, I got to break up pages and from 4 or 2 meg to 4K. And that can take a while, especially if you have an HA event and a host fails over and virtual machines are starting to come up. Well, a host can hit 94% really fast, and TPS, it's fast, but it's not as fast as a host failure, high availability kicks in, and it's trying to bring up hosts as fast as possible. The hosts are going to come up before TPS has gone through and said, okay, I need to start breaking a page across these pages and work it like that. Nah, not going to happen. However, I'm going to show you how you can force TPS to work at the 4K sector. I don't really recommend doing this for things like Java app environments. There's a VMware article on extended page tables. You can Google it, just extended page tables VMware 5.0. But, take this for what it's worth. Realize, okay, is my environment high intensive memory or what? Just realize what I'm doing. I'm doing it in a lab, but I've seen a lot of people do it in production. I've done it in production environments. It's worked fine. Haven't seen too much of a CPU overhead, maybe about 3 to 5% more, but well within acceptable ranges. And for TPS to work in its maximum efficiency, you should run VMs together. Meaning, if you have 3 hosts, I'm just using 3 because it's easy, and you have Windows, Linux, and BSD. Chances are the Windows hosts are going to share more in or the Windows VMs are going to share more in common with each other than Windows mixed with VMware's on the same, or Windows mixed with Linux on the same host. So if you have 2 Windows VMs running on the same host, probably going to see more TPS than Windows sharing Linux on the same host. So, you don't have to. TPS is still going to kick in, but it's just for consideration if you're running a memory constrained environment. So now I'm going to show you how to enable it, and I'm going to show you the difference. So I have a VMware View class that I've kind of designed running just without vCenter, but I'm showing you with small page tables enabled. Now, as you can see down here, there's about 7.27 gigabytes shared. That's a lot, and 186 private. That means there's 687 megabytes that are unique to each virtual machine. And there's 7 gigs that is shared. Oh, and it just went down a little bit. So as you can see, working really well. So as you can see, even though I have provision configured 20 gig and it's saying a whole bunch more is there, TPS is saving me a lot of memory. Almost 7.27 gigs. That's pretty good. And most of all of these are Windows hosts other than the ESXi and the router. And now I'm going to show you kind of what it looks like on a standard uncheck box marked host. About 4 gig. Now, it was a lot better the first time I did this, but I believe this may be because I'm running the ESXi, this 142 box that I have in my cluster is actually, well, no, it wouldn't affect it. But, 7 gigs versus 4 gigs, that's a pretty good bump. I'll save any RAM I can get, and this can get much larger on larger environments with more servers. It's really cool. But where am I trying to go? Whew. Okay, so now I'm going to show you where to set this setting, and you can be the savior of the day in any. Hey, look, it's going down more. You can be the savior in any RAM constrained environment that isn't super CPU intensive or doesn't have a lot of dynamic memory applications. This can be a lifesaver, and you can be a hero. So basically, okay, we have a ESXi host here. I'm going to go to the Configuration tab, Advanced Settings. I only recommend changing stuff in here if you've been instructed by somebody to do so. Don't go flipping switches in here. It can really destroy a ESXi host, and yeah, bad days all around. So I'm going to go over to this left side pane, come down to memory, and I am going to come to this one particular box. It is going to say mem.allocate guest large pages. I am going to change this to 0. Now, for this to take effect, I have to reboot my ESXi host. Not something I really want to do right now because I really don't want to wait for it all to come back up. But, I'm just showing you where you set it. You'd hit 0, hit OK, reboot the host. I already have it set up on this .100 server, so I don't really need to set it, but I'm going to show you what it looks like when it's set. And it's 0. I've already rebooted that one before. Don't need to reboot it again, but it helps a lot. And I'm even running an older processor, and I'm running about this many virtual machines on a single host. And it's doing fairly well. Not a lot of CPU usage. Maybe I can go to memory. I'm getting a good amount of shared common. That's pretty good. So, back to the slideshow. Okay, so other than TPS, there are a few things that VMware can do to help save memory. And I think this is another reason why they enabled large page tables and extended page tables. It's because memory is a lot more reclaimable than CPU. If you look here, you can see swapped, compressed, and ballooned. What balloon means is, okay, it's going to try to force all the memory of the virtual machine into a swap file, and then any active memory comes back out. Basically, there's a driver in the VMware tools called, I can't remember the acronym, but it's a balloon driver. It basically forces everything to page, and then just as blocks become active, it loads it back in the RAM. Compressed means it's trying to zip pages in RAM real time that it does not feel are active. And then swapped means it's actually, it's gone through balloon compressing, and it's actually having to swap the spindles. Very, very slow, very bad. People will complain. Ballooning, it's slow for a little bit, but it works well. Compressed, slower than ballooning, and swapping is the slowest. Very bad. Assign what you need to a VM. This is a really strong point. A lot of people will just assign these large amounts of RAM to virtual machines because they can. And they go, oh, well, it's only using 2% of the memory I assigned it. That's good. No, it's not good. The virtual machine should be using a little bit more than that. You're running off shared resources. Just because the virtual machine says it has 2% that it's utilizing doesn't mean that's good. Higher RAM utilization, like 65 to 75%, can be good. That means you're utilizing the resources you assigned it. And I don't say run it higher than that just because you need some of that overhead for unexpected things like end of the month transactions, beginning of the month transactions, and other things that just, may spike memory 20% and you don't account for them. You can actually go higher, but you really need to monitor what your virtual machines need, whether that be over 2 weeks or 2 months. Monitor what your virtual machines need, scale back as needed. And it's a really big problem with a lot of environments is, they'll spend $125,000 on these new servers, go virtual, and then they'll say, oh, why is this performing so bad? Well, it may be because you're just not provisioning stuff right. So I'm just using this Active Directory server as an example. As you can see, I'm using 55%. And I go and look at the services, say, okay, well, is there anything that would cause this to maybe spike? And as you can see, it's, basic Active Directory server with a few other features. Certificate authority, DHCP, and DNS, and just the web server because I have web enrollment enabled. Now, Active Directory servers really don't use a lot of RAM. Even in high transactional environments, I don't see a lot of RAM being used on those. So an Active Directory server can very well operate off of less than 1 gig of RAM. So if I was going into an environment and they were complaining about, oh, we just don't know what's going on, well, something like this may concern me. Okay, well, you're only using really half, and you're not paging much. But what I may say is, okay, well, let's scale this back to 768 or 700 or whatever, to try and get it to fit in this range. It completely depends on the environment, though, and what I see from, okay, this is a normal utilization of RAM from day to day. And another thing about VMs that you can do is you can always hot add RAM and CPU. CPU is a little different. I think Windows requires data center or above for you to do it, but memory, pretty sure standard and everything does. Yeah, standard and up does it. So if I had this enabled, I could enable hot add memory, and when I would come back to hardware, there'd be a slider that I could just up the memory. As well as CPU. I can hot add CPUs. So even if I under-provisioned it a little bit and people came back to me and said, hey, look, the environment's working better, but we're having this issue with this one server where it keeps complaining about low memory. Well, I don't have to take it offline because I can just add memory into it lively. A lot of people don't know that exists, but I think that's only in standard and higher for the VMware editions. So keep that in mind. Using SSDs for swapping. This is really cool, especially as SSDs are becoming more affordable. I'm really into the whole, I don't like any local storage. Use an USB or auto deploy if you want. But as SSDs become more and more affordable for servers, adding 2 SSDs in there, not the worst thing in the world. especially if you're RAM constrained and you're like, oh no, I hope I don't have a failure of a host, because even though I have HA, I don't know if I have enough RAM to satisfy it. And this is also really important in VDI deployments, because you may have 80 virtual machines to one host, and if one host fails over, well, are you sure you can guarantee enough memory in the remaining hosts to handle a failover, especially if you're on a constrained budget? And VDI is not the cheapest thing in the world, so it does happen where people just underscale memory a little too much. But it's a really great way if you can't, take down your host, add more RAM, you have a low budget. RAM's pretty cheap nowadays, but, you can get a lot of SSD for under 200. So I'm going to show you how to do this. And this is really great for a lab environment, especially if you have 32 gig of RAM and you know you're going to go over. You click on your host, configuration. Then we're going to go down to host cache configuration, and this can be done live. And as you can see, I already have an SSD data store added in. I'm just going to go to properties on this, and then I'm going to allocate space. Now I have 19 gigs free. I'm not going to use up my whole drive. I could if I want to. I don't want to. But I'm just going to do 3 gig. So now what's going to happen is when my host says, going to go back to this screen, when my host says, okay, I've tried to do ballooning, compression, and swapping, instead of going to a disk, it's going to swap to SSDs. And SSDs are a multitude faster than normal hard drives. I mean, we're talking maybe it would take 100 hard drives to equal 1 SSD. It's super fast, latency is super low, and then a lot of times, I don't want to say all the time, but in a lot of times, people really won't know the difference. And yes, like I said, this can be enabled live, so it's a really cool feature, especially for home users or lab users, and you're running out of RAM. So I want to disable it. I'm just going to hit OK. I don't really need host caching. I have about 40 gig. Alrighty. And enable DRS. DRS is your friend. A lot of great things you can do with DRS. It's not there to hurt you. Enable it if you have it. There's some use cases where you won't want to enable it, especially if you're like doing some unsupported virtualization of storage, like running FreeNAS appliances, and you don't want a FreeNAS appliance going into another FreeNAS appliance. But, well, that's more storage DRS. But either way, DRS can automatically balance your hosts. Aggressive means it's going to see the slightest improvements and try to balance the cluster. Conservative, it kind of lets a little more slide. Usually leave it in the middle unless you have unless you really know what you're doing. Yeah. I've seen a few environments where they put it all the way up to aggressive, but not too many. Partially automated. This means you power on another virtual machine, it's going to try to select the host, or if you have to reboot a virtual machine, and I mean go right-click on the virtual machine, restart, you're not doing it from within the guest. It's going to try to place it on a specific host. I leave mine at manual because it's a lab, and I don't want ESXi going into ESXi again and creating a division by 0 and blowing up my apartment. That would be bad. CPU. A lot of ways to monitor it. The most common way is people go click on here, click on your host, go to summary, and then they look and say, oh, there's my CPU usage. Not always accurate of what may be slowing down your environment. Excuse me. There's a tool for this. It's called ESXtop. And I'm going to show it to you. So I'm just using PuTTY. It's not going to work by default, so I'm going to show you how to enable SSH to your ESXi host as well. Go to your host configuration. Go down to the software tab and security profile. And we go to properties up here in the top, not the second one. We can if we want to do the firewall. I don't. There are use cases for it. But there is basically start automatically if any ports are open, stop when the ports are closed. Again, if you were going to the firewall and you just close the SSH ports, the service would stop. If you open the ports on the firewall, service would start. Because this is a lab environment, I have it set to start and stop with the host just because I don't really have a extra monitor going to it and I don't really care to. But if you wanted to, you could also do start and stop manually. If you're doing a production environment and you need to get into a host temporarily for SSH and you do not want to use something called the VMware Management Agent or the VMA Management Assistant, do start and stop manually. Don't leave your SSH open. You can, don't recommend it. And if we did start and stop manually and it wasn't, I'll just show you. So if we did start and stop manually, it would show like this, start. And there we go. Only it would stay here. And as we can see, service is running, and I'm going to hit OK. Now it's open. I type in the IP address of my ESXi host, hit open, and it's going to give me a prompt, login. I'm just logging in as root. And use my super secret password and clear. Now, there's a cool thing that a lot of people don't know about, and it can be helpful. If you're in the screen when you SSH into your host, if you type DCUI, you get your login window for ESXi. This is especially helpful if you bought servers without ILO or an IP management or management over IP interface. Yeah, you can do everything just like you had a monitor here. A lot of people don't know about this for some reason, but I can come in here, view system logs, just like I was at a monitor. Really cool stuff. To quit, I just hit Control-C and then type clear. Usually it like auto clears, but it didn't that time. So, where was I going with that? Oh yes, ESXi top. ESXi top is probably the most cool tool ever. It presents you a lot of information. Of course, if you don't know what you're looking at, you may not understand what all this information means. I'm going to cover the basic stuff just because ESXi top is a really powerful tool. There's a lot of stuff to do with ESX top. The most thing I'm going to report on is the CPU ready time. It's this column. It's in there by default. You don't have to configure anything. What CPU ready time means is the virtual machine that's using shared CPU resources and time is ready to complete a computation. The virtual machine is ready to run code against the physical CPU, but it's told, hey, wait. And so the virtual machine is ready to compute this code or whatever, and the hypervisor or the scheduler is saying, no, wait. It's a little backwards, but if you think about the virtual machine being ready and the CPU not being ready, kind of makes sense. So you may say, okay, what does this percent ready mean? Well, basically, like I just explained, there's a percentage value to these CPU ready. And as you can see, some go from 1 to 0.0 or whatever. Commonly, you want to see as low as you can get it within performance acceptance. And generally that means you're from 0.00 to 1%. 1 to 3% is probably okay. 3 to 5% is where you're starting to see some CPU bottleneck. You're basically what the CPU is saying is, hold on, I can't process all these requests. Give me some time. And you could possibly see that in the summary, it's not saying that your CPU is overburdened. Well, that can be because you've assigned too many vCPUs to the CPU, things like that. This CPU usage right here is not always accurate. Well, it doesn't always give you the whole story. I'll say that. Sorry. So this is really a good place to see and say, okay, is CPU actually being my bottleneck? And if it is, this is going to show you. Another cool thing you can also do, if you hit F, you can start changing the columns. So I'm just going to hit H so I can see CPU allocations, and I have some new tabs. Of course, ESXi top is not only for CPU. You can also do memory. So I can actually start seeing detailed memory information here. So I can see swap, I can see zip, I can see shared, I can see my physical memory, how much I have free, so on and so forth. Or I can go to disk by hitting the letter D. And M is memory. Sorry, it's like 1 o'clock and I'm getting a little tired. So I can actually come into my disk and see, okay, where my read-write's going, what's busy, what's not. And I can see my HBAs. And if you don't really have a, on your head, or, you just want to do it an easy way, you can get the HBA here. So I'm just going to use, I think I used 34 and 35. I go to the host, I go to configuration, storage adapters, and I said 34 and 35, right? So, okay, this is my Western Digital drive and my Western Digital drive. And I can look at 38, and that's my software SCSI adapter. And if I wanted to, I could copy this nice new name, storage, device, and match it up with the devices here. And since I know my my virtual NAS, I'm running my iSCSI storage as a VM right over here. I know that, okay, this virtual machine is basically using both these two disks, eager 0 thick, to do their read-writes to. So I can go, oh, okay, that's where my performance is going. And I can also see network. So here I can see, okay, how many megabits and whatnot are my network adapters doing, or VM kernels doing, and where they are. I can see most everything is on vSwitch 0, some is on vSwitch 2, or vSwitch 1. This comes really in handy if you're facing a network issue and you're like, where is blah, blah, blah coming from? Well, this gives you a little bit of information. I think I covered everything in here. I don't know, there's a lot of stuff. You can also hit F to get more information. I'm just going to quit. Alrighty. Hyperthreading. A lot of people confuse hyperthreading with actual physical CPU cores. They are not physical CPU cores. They are a way for the CPU to start scheduling processes at the same time. However, that does not make up for another physical core. It does help in medium to low end CPU usage. So if I go back to my host, for example, AMD doesn't really have hyperthreading. They have something in their newer stuff. They have some kind of weird stuff, but this would be kind of okay for hyperthreading. I might see a good reduction in CPU ready time just because the processor is trying to help co-schedule tasks that are being performed. It can help into low to medium environments. However, when a environment becomes saturated or a host becomes saturated, the hypervisor can start getting confused and saying, I'm seeing these cores, why are they not performing the way I want to? Because you're going to be bottlenecked by your physical cores. So realize the limitation. It's a hidden threat that a lot of people don't think about, and then they go, oh, it was hyperthreading. So sometimes hyperthreading can actually work against you more than it can help you. And it's not because hyperthreading is evil, it's because you're overestimating what you have when it's not going to actually perform the same as a physical CPU. Intel or AMD? Big question for a lot of lab environments. I like AMD for things like virtual desktops because I get a high core density and it seems to perform better and things like that. However, Intel just has great offerings and higher performing processors. But really look into what your budget has. You know, if you're worried you don't have enough cores or you expect a lot of growth of virtual machines, you know, a large core density with AMD may be a little bit cheaper option, and you know, okay, I need the servers there, but I know they're not going to be CPU intensive. AMD might be good. Intel is widely used in the production environment just because they're higher performing. You look at some SAP marks, and I'm just going to go to one of my favorite websites, and the tech. And the tech. I like the site. There are a whole bunch of other sites like it, but they have some enterprise CPU. These guys have some really good, yep, here it is, CPU benchmarks. So I'm just looking up a server CPU, the Opteron 6300, and I can start to see, you know, how it scales when you have a 2-socket motherboard versus a 1-socket motherboard. Generally, as of right now, Intel does have the server market. There are a lot of things that AMD does have that are really interesting, but if you want raw performance, Intel does lead the way. But, you know, it comes down to what fits the customer, what fits the project requirements, many other things. You know, do what's best for the environment and the company's needs, not, you know, you favor this brand over this brand. You know, focus on fulfilling the customer's needs, because that, at the end of the day, that's what they're going to remember. That's what they're going to look for. Gigahertz versus cores. A whole bunch of people are at fault for doing this. They will see the low-grade Intel 3.2 or 3.8 gigahertz Pentium server processor. And yes, they do make Pentium server processors, or at least some vendors put Pentium processors into servers. And they go, wow, that's really fast. And then they look and they say, wow, 4 cores. And they go, oh, well, that's actually 4 hyper-threaded cores and 2 physical cores. So that's a really big difference. Gigahertz is not completely accurate to how a CPU will perform. If you go from Ivy Bridge to Haswell, there's a sizable architecture gap. A 2.0 gigahertz CPU from Haswell may outdo a later generation Ivy Bridge that's from 2000 and whatever, 2011. I'll just say that. Even though the Haswell is a lower gigahertz, the Ivy Bridge, has a weaker architecture. Look at benchmarks. There are a lot of case studies, especially if you're doing them for a production environment, that any reputable vendor will give you a case study, or at least some kind of performance charts. I guess I'm not so over the cold as much as I thought. Just realize that, gigahertz doesn't mean everything, and more cores doesn't mean everything. Yes, you can have a 16-core, 1.6 gigahertz processor that, if you're just running a few VMs, may be kicked in the butt by an Intel processor that has 4 cores running at 3 gigahertz. Performance is really relative on what your use case is. Don't just look and say, more cores, more gigahertz, that's what I want. Well, yeah, but that may cost you a lot more. Try to look up benchmarks. They're out there. And look up case studies. At a minimum, I'd say go for something that's 2.0 gigahertz or more. I say that because there are a lot of virtual appliances out there that if they detect something slower than 2.0, they'll say, hold up, I'm not going to run on this, blah, blah, blah. 2.0 seems to be kind of the breaking point where a lot of things like VSA, I think Barracuda's email spammer wants a 2.0 gigahertz processor. And yeah, just weigh the pros and cons. But I'd say 2.0 at a minimum. Network. There are a lot of cool things you can do with network in VMware and other hypervisors for that matter. There are 2 most common ones in VMware are the E1000, which is a Intel kind of based one, which doesn't really require VMware tools, the VMXNet, which is kind of paravirtual, and it does require the VMware drivers. And there's the E1000E, which is an enhanced version of the E1000. A lot of people don't really use that because it's not there by default, and I think it requires VMware tools, if I remember correctly. Cool thing about the VMXNet and why you should always use it is, 1, less CPU interruptions, you get the maximum throughput. If I go to my virtual machine, and I know I have the VMXNet 3 adapter in here. You can see I have it's reporting as 10 gigabits. Well, fun fact, it can actually go a lot higher than that. Some people have reported 40 gigabits per second, but I have yet to see that. So if I have 2 VMs, I'm going to use a spam filter and an Exchange server as an example. And I say, okay, obviously these are going to do a lot of network traffic. Either the mail is going to come in, hit the Exchange server, then go to my spam filter, and then back to the Exchange server, or, it's going to go to the mail filter first, then the Exchange server. It depends on who my vendor is, how they see things. That's a lot of network traffic, especially in larger environments. And it doesn't apply just to mail. It applies to everything that does network. Like if you have a SQL server and then immediately a front-end web server, front-end web server or whatnot, you're going to be switching, as long as those 2 virtual machines are on the same virtual switch, they're going to be switching at RAM speeds. They're not going to touch the network. So RAM is super fast compared to going from the virtual machine to the VM to the physical network adapter to the switch to the other host that does the exact same thing that I just mentioned, there can be a real lifesaver there. I mean, you can save up to 70 gigs of network traffic a day just by setting affinity rules and saying keep these two virtual machines together on the same physical network, or virtual network, I'm sorry. And a lot of people don't know that. But if you use the VMX-Net 3 adapter, you can get some really cool performance savings on your network. And to do things like DRS rules, just going to go into that for a little bit, we go to the DRS group manager. Sorry. And so I'm just going to use two virtual machines. I don't really have a email server and a Barracuda appliance or spam filter set up. So what I'm going to do is I'm going to use my two connection servers. And I'm just going to call this stick together. Okay. So I got my two VMs called stick together. And I want these two hosts in my DRS group. I'm going to say hosts for stick together. Okay. Cool, so now I got these two forms filled out. And you'll see why these come in handy in just a second. Now I want to make a rule. So I want to keep virtual machines together. I'm going to select the same two connection servers, and we're just going to pretend these are an email server and a filter. I'm going to say email and filter. Just simple. And as you can see, this rule is going to apply to the virtual machines and the hosts that I selected earlier. So now that I got this, I can say keep them together because I want these to keep together on the same host, so I'm not saturating my network more than I have to. And this really comes into play, especially if you're straining a gig network. And that's why I always say, you can go really, really far with a gig network. 10 gig is awesome, but there are a lot of things you can do to really optimize your 1 gig networks. If I wanted to, and I said, okay, these are connection servers for view. Obviously, I don't want connection server 01 and connection server 02 running on the same host. I could say separate these two virtual machines because I want them to fail back and forth. I don't want them to stay together. So I can separate them. Or I can just say, virtual machines to host. I can say they always must run on the same host. I never want them apart, which I don't want. Should is best effort to keep them on the same host. Must not run on the hosts in group. I don't want these on these cannot run on the same host together. I'm not entirely sure if an HA will just say, well, you guys are going to make love on the same host until I get this all figured out, but I don't think it will recover from an HA event. Should not, I know will recover from an HA event. It's just going to throw an error in DRS saying, hey, look, you got two virtual machines. They shouldn't be on the same host. What are you going to do about it? But for right now, I just want to keep these together. We hit OK. And as you can see, I have my rule set. And it's just going to show me the virtual machines that are in there, and it's going to show me the type and who it was defined by. And I can hit details just for more option. I don't have any conflicts, but I haven't applied it yet. Virtual machine options. If you had a DRS environment and you wanted to say, I don't want this virtual machine moving around a lot, you could change these options. Or if you say, I just want this one to always try to perform its best, fully automate it, and it will try to move it around as needed. Power management. A lot of people don't know about this, and it can save your company a lot of money. It will make people happy. Power management. Basically what this does is, okay, let's say you work for a school, or a bank, and your day is from 8 to 5, and then the rest of the day, well, you really don't have that much going on. So why should you leave your servers running the whole time? Well, what this allows you to do is basically say, okay, wow, I'm really not over that cold. It can basically say, okay, when resources meet a requirement, start shutting down hosts. And a lot of people go, whoa, 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 I don't want to shut down hosts because how do I power them back on? Or, whoa, 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 what happens if I have an HA event? Well, there are a lot of things you can do from here. You can say manual. It's going to say, hey, look, I recommend you can power this host off. It doesn't have a lot of load, and I have resources to fail over to. And it's going to recommend it to you. It's not going to shut down any hosts or vMotion it. And I should add that on. It will automatically vMotion virtual machines off the host that it's going to shut down. It's not going to power off your servers or virtual machines. And then you have automatic. Basically, it's like it says, it'll apply recommendations to meet HA. It's also going to take in other host utilization requirements, and it will power off if it says, okay, look, I can get rid of this host, don't need it running. And just like DRS before, you can move the wheel up and down. If you do it conservative, it's going to apply power recommendations that meet vSphere HA or user-specified capacity requirements. Aggressive, it's going to try more aggressively to save you power. Leave it in the center unless you have a reason. But you can really save a lot of HVAC cooling and things in the summer, especially in a school because they get out during the summer. You don't need your host running 100%. You can really get a long way with that. Although you do have to have something like Wake on LAN, IP management, or ILO on the host. You have to configure those and then set it up. And I just don't have it set up because I only have one host, so VPN probably wouldn't be a good option for me. And sorry to get off a little track there, but just some cool features in DRS. If you need some more advanced features, there are things like VMDQ and Nexus 1000V. What Nexus 1000V does is an advanced virtual switch. I really wish I could say I've used it a lot. I haven't, because virtual distributed switch and virtual standard switch do a lot of great things, especially in 5.5 and 5.1, that kind of make the Nexus 1000V kind of a head scratcher. But in larger environments, these Nexus 1000Vs and things like VMDQs can be really good. There's also some really cool stuff with the UCSs where you can start divvying up physical 10 gig network adapters into smaller 1 gig adapters, or I think you can actually go lower than that, but 1 gig I believe is what it was last time I used it. So if you have a 10 gig network adapter, you can say, okay, I want 10 virtual 1 gig interfaces, and then you can start assigning those to switches, and you can start carving up that 10 gig pipe more effectively. There are a few other ways you can do it. Okay, so I'm actually going to show you something kind of cool. Whoops. Go here. Okay. A lot of people, servers really come with like 4 gig ports on the motherboard, and then you can do an add-in card. So standardly, what a lot of people will do is they'll assign like one VM kernel to 1 or 2 NICs. Well, there are a few things you can do with virtual standard switches, even if you don't have virtual distributed switches, to do things like network I/O control and whatnot. What you can do is you can actually set all your paths to active, like I have done here, and I've VLAN tagged. So my VM network is VLAN ID 123, vMotion is 25. I do this because vMotion is going to send in clear text and storage is going to send in clear text. However, I have my storage completely separated. So what I do here is I go in and I say, okay, I'm going to go in here and edit my vMotion. Traffic shaping. Okay, so if we all assume this is, well, this is all 1 gig networking, I can go into here, checkmark status, click enable, and I'm going to set some traffic shaping. So I want my average bandwidth to be, I'm sorry, it's late, so if my math is off, I do apologize. I'm going to say I want the average bandwidth to exceed, to be about 3 gigabits, and I want my peak to be 3.5, and I'm just not going to even touch the burst size. So now I have, click this, hit OK. So now I have a burst of 3.5 gigabits per second that I can send out over my vMotion network. And virtual standard switches will only do egress traffic, but if you set all the vMotion kernels to egress only, then guess what? You kind of rate limited how much you're going to send and receive on both hosts, because you can't receive more than what's being sent from the opposing host. So you can actually go here and say, okay, I have 6 gigs, or I'm sorry, 5 gigs. Wow. Yeah. Talking late at night does things. So now I have 3.5 gigabits of network speed that I can do from my vMotion network. And it's VLAN tagged with VLAN 25, so, you know, I feel a little bit safer about sending stuff in clear text. And I could say, okay, well, my VM network, go back into here, and I can do the same thing. Enable, I just want to make sure that it's capped here, and management really doesn't use a lot, so don't leave your management at 0. Please put it on a different VLAN or physical switching. And I can come into here and I can start carving it back. Now, I don't recommend setting it to 100 kilobits per second, but, you know, it's just an example. How to carve out a larger portion of network throughput into more manageable needs. So even though all these are fully up and whatnot, I don't really have to worry about failover so much of saying, like down here, you know, if a NIC failed, I'm just using this as an example. I know that there would be some other things that go into effect, but I'm not down to, say, 1 gigabit. Well, I guess I could have done it with the other one. But, you know, if I lose one of these NICs, I'm still pretty good off. I don't have to worry about, say, my vMotion network go down. You know, it will just distribute across whatever network, and those values that I set will be carved out. Now, of course, if one fails, you know, I'm oversubscribing what they can do, but I'm, you know, hoping that I don't lose 2 network adapters at the same time. So my vMotion network that I set at 3.5 gigabits per second doesn't try to use, you know, 3.5 gigabits per second and take out all these network adapters, because vMotion will suck up your network bandwidth faster than anything. Hardware-assisted TCP offloading, TOE, really good if you're running iSCSI or things like that. Basically what happens in an iSCSI network is the iSCSI packet comes in. Okay, let me back up a little bit. I'm going to show you. Okay, so here I'm using the software iSCSI adapter. Basically what's happening here is when a TCP packet comes in, it goes to the CPU to decapsulate the TCP packet and then get the payload out of it. In TOE, oh, it didn't like it, took away its iSCSI adapter. In TOE, I could come over here and it would actually show an adapter somewhere in here that I could actually bind an iSCSI kernel to and have some assistance with offloading that TCP frame. Where that comes in handy is if you're running a CPU saturated environment or VDI and you want the actual physical network adapter firmware or what have you, uncapsulate the packet and then send the payload straight to where it needs to be. Helps a little bit in performance. I've seen some benchmarks. Wow. A software iSCSI adapter on a saturated host can use about a core or two, but hopefully you're not getting to that point. And for all intents and purposes, to get a network adapter that does TOE is not really expensive. It's relatively cheap. Most Broadcom network adapters do it. So yeah, I'd use it whenever necessary or whenever available if you're doing iSCSI. There's also hardware iSCSI, but I don't really see too many people using that because hardware iSCSI is kind of expensive, but you can use it. VLANs are your friends. I cannot stress enough that do not build your network flat if you're doing VMware, or any virtualization for that matter. I don't really know of any VMware or any hypervisor that encrypts things like iSCSI and NFS, or their vMotion, live motion, whatever they call it. It's all clear text, meaning if I had a sniffer on this VM network right here, and this was also my vMotion network. If I vMotion a machine and I had a sniffer capturing VM network traffic, I could essentially download all the RAM, anything in RAM, to my virtual machine, go back, open it up, and potentially open up a file that somebody had open, such as a important Word document or an accounting document. And while that may seem a little far-fetched, it does happen. I've spoken to a few people who are pen testers, and they've used things like that. It's a little scary, but basic security design: separate your networks, separate your storage, separate your whatever you're doing. Separate it as much as you can. VLANs are necessary if you can't physically separate it. You can also use different networks, but again, realize you can also read stuff. You can also read that stuff. VLANs are your friends. Like how I have set up here. I have the VM group on one VLAN, vMotion on another. I should really have management on another network. A lot of people will also go, hey, look, I have my storage network secured. And they go, I'm using CHAP. Well, CHAP is just authentication. It's good protection to use, but it does not save you from people reading your network. It's still clear text. It's just authentication, not encryption. Please don't confuse the two. Just because you can authenticate to something doesn't mean it's an encrypted connection. Alrighty, it is really getting late, so storage. a lot of people really don't update their storage firmware. This is really good to have. It can improve performance a lot. Keep in mind that most storage arrays that are active-active can be done live, but you should probably plan it within maintenance. Also, search if your providers provide drivers for your ESXi hosts. A lot of people go, oh, there are drivers for that? But yes, there are. Or storage type plugins, I guess it would be more proper. What they can do is help you load balance physical network activity, multipathing. EMC has one called PowerPath. Basically, they're more efficient than the prepackaged ones in VMware. In VMware, you have a few. Round robin, mostly used for active-active. I think they really recommend it for a lot of things. But fixed is also for if you have an active-passive array, meaning there are two controllers in the back of your array, one fails, it takes a little bit of time for the other controller to kick in and say, I'm here, I'll service your storage needs. And that can be an issue. Yeah, you probably don't want to set to round robin because you might get thrashing where it's trying to talk to one controller and saying, hey, look, I want to do traffic. And the controller's saying, all right, I will. And it starts to compete with the other controller. Bad things happen. Not all arrays do that. Some will just reject it. But most recently used, what this is going to do and how this is different from fixed is it's going to look at the last active path and use it. Fixed will fail back to a path, I believe. So if you have two paths to storage and one path goes down and then you re-up the path, fixed will go, oh, the old path that died is back up and go back to it. Most recently used does not fail back. Keep that in mind if you're designing something. Sorry about that. If at all possible, make sure your array supports VAI. What VAI helps with is things like block zeroing. So if you go and you make a eager zero thick disk, which you probably want to do eager thick 0 if you're doing something like a high transactional SQL database. Wow. Sorry about that. Or a high transactional server where it's not going to have to go, okay, I need to write a 0 before I can write data to this. If you kind of think about it, thin provision, how it only writes data that's needed to the disk, well, because of that, the array has to zero out a bit before data is written to it. So you can lose an IOP. And in high transactional environments, it may become a factor. Another cool thing is thin provision reclamation, meaning, okay, so we're all familiar with thin disks, or if you're not, what happens in a thin disk is, let's say we create a 40 gig thin disk, and we write 10 gigs of data to that 40 gigs. Well, that thin disk is only going to be 10 gigabytes in size, not 40. Okay, well, what happens if we delete 5 gigs of the 10 we wrote to that 40 gig drive? Well, to the data store, it's still going to look as 10 gig. What VAI can do is actually say, oh, look, the data is not there anymore. I'm going to trim it back to 5. And that can be really helpful because a lot of people will see thin disks and they'll go, oh, let's just delete data off of it. And then they wonder why their data store keeps growing. VAI can help this. There's also a free way to do it with VMSK tools, I believe it is, that you can shrink it, or you can just do a storage vMotion. On copies, what it's going to do is it's going to offload the vSphere element of it as best it can and attempt to let the hardware start copying the virtual machine files or what have you, instead of trying to use vSphere, which hardware is going to be faster than software. There are a few other things like atomic testing and whatnot. I'm not really going to get into that because these are probably the three most features that I hear people wanting to talk about. But I can do it later in a GUG if anybody wants to go over storage. I'm doing one next week actually, so we'll go into it a little bit more then. Understand the difference between file and block level storage. Where to begin? There are a lot of differences between NFS and iSCSI. For a lot of environments, mostly SMB, just a few servers. They need HA. They're probably running something lower like a HP MSA or a Dell MD, whatever. Something lower end that's fit to their needs. They might be fine with an NFS storage device. That doesn't mean to say that NFS is only for SMB. It's most certainly not. But NFS is very easy to set up, low management overhead, performs very well with things called jumbo frames, where you can up the MTU size of what goes over your Ethernet, and get a nice storage performance boost. And it's generally cheaper for the end user, for the client, I should say, and it performs pretty well in a well-designed environment. However, there's some caveats. In VMware 5.1, I don't think in 5.5, we may see it in 6, I don't know. VMware only supports NFS version 3, which means there's no authentication, and you go, oh, well, why is that important? Well, for VMware, you have to map people to root. So, if you're familiar with what that means, that basically means that you're giving root privileges to a file share, or admin privileges to a file share, which, if you're on a flat network, is a time bomb waiting to happen. It's only a matter of time before somebody goes, let me try to copy that virtual machine, or they find it. In mapping is not hard. Script Kiddie could do it, and then lo and behold, they have all their data, your data, and they're booting it up, and they're going, wow, look at all this stuff. And a Windows machine is not hard to hack without a domain password. It's super easy. But anyway, file is a little bit slower than iSCSI. It can perform very well to iSCSI, but NFS has to go through an operating system to complete writes and reads. So you have a host, it goes to the network, it goes to an NFS server. That NFS server takes that packet through the operating system and then completes it. A little slower than iSCSI, however, with processors getting faster, memory getting faster, L2 ARC, and all these other things that are, okay, write to RAM first because disks are slow. A lot of cool things are happening that make NFS really fast, especially with SSDs. The other thing is, because VMware doesn't support NFS version 4, at this point in time, with 5.5 out, and it's probably going to support it in the future, but you don't get multipathing, so you're kind of struck into one path. There are things that vendors do to leverage this, because NFS version 3, has been around for a while, and this is going to be a problem. Some vendors will have a NAS that makes a virtual IP address, and then has, multiple network interfaces that act as uplinks, and then shares it, and you can run those uplinks anywhere. And then they're block level storage devices. iSCSI is pretty good. I like it for server virtualization. There's a little less latency because you're going on the block level. It's multipathable, fairly easy. Higher performance. And I don't know, I like it a little bit more. It seems a little bit faster. There are more arrays that support VAI with iSCSI versus NFS. It depends who you're looking for. But one cool thing about NFS is if you're using a VDI environment, you don't have something on iSCSI, which is called locking. Since you're going through an operating system stack, your locking is reduced to basically nothing. So in a VDI environment where you have maybe hundreds of thousands of desktops trying to access random files, NFS will handle it much better than iSCSI, which is going to attempt to lock a little bit of the LUN and say, hey, look, I need to talk on this for a second. Just keep that in mind. But I like iSCSI. It's a little bit faster. Less people mess with it. And I think it's easier to troubleshoot. But fit for what the customer needs. Ensure redundancy using multiple paths. If I could figure out what was wrong with my lab, I think it's because I'm doing virtual and virtual. That network interface I removed, you can basically make two iSCSI VM kernels, attach them to, let me just do it real quick here. Add, you have to use an unclaimed adapter. And I'm just going to finish that out. This isn't the proper way to do it. I should really upload a YouTube that shows you how to do it properly. Basically, to an iSCSI kernel, you can only have one uplink active at a time. So on this one, I'm going to set, oh shoot, sorry about that. On a vSwitch, you can have two active, but on the actual VM kernel, you can only have one active at a time per VM kernel for iSCSI to work properly. And so on iSCSI 2, I have 5 active and 6 unused. It has to be like this. And on iSCSI 1 VM kernel, I have 6 active with 5 unused. And then I could come down here to storage, and I go to my software iSCSI adapter. And I can add these two. And then now for some reason, I think it's because I'm doing virtual and virtual, those paths will always be unused, and I think it has something to do with promiscuous mode, which is a little bit, it's getting a little deeper in there, but I don't think it's going to work. Yeah, no, it still sees it, but that's how you would do it. Use read caching when applicable, especially if you have an older array but you have newer servers. A lot of people see servers. Servers are cheaper than storage. You can get a lot of storage for cheap now, but servers are pretty cheap to upgrade. And again, like I said, those require flash drives in the servers, which are also cheap. And you can use those for read caching, so you can help leverage your older array for longer. Virtual machine optimization. Use paravirtual when you can. It's a really awesome thing. I like to use it. You're fine without it, but if you have a high transactional SQL server, Exchange server, other things that do a lot of I/O to disk, you may want to look into the paravirtualized SCSI adapter, which, let me close this out, keep clicking on it. Alrighty, so I'm going to show you how to do paravirtual. I did this Wednesday, so I need to check to make sure which one I did it on. Okay, well, that's my domain controller. We don't want to do it on that one. So I'm just going to do it on this connection server. Hopefully there's nothing on it. I don't think there is. Well, this is on a ZFS store, so it shouldn't take too long. Skip. Okay, so paravirtual drivers do not have a native driver in Windows. They're accustomed to VMware, so you have to install third-party drivers. Well, if you try to install third-party driver, if you wow, tripping over myself here. Basically, what happens is, if you're trying to swap out the paravirtual driver, even after you install tools, Windows probably isn't going to know how to handle that. So what you got to do is, what I'm about to show you, is you have to get Windows to install the driver as somewhere it can look right off the bat. So I'm going to go to my VM. And as you can see, I only have one hard disk. And for this, I have the LSI Logic SAS, not the paravirtual. So I know I have tools already installed, and I'm not going to really show you how to do that. Whoops. Jesus, late. So I'm going to go into hard disk. Next, create new virtual hard disk. I'm just going to make this a gigabyte, and I'm going to make it thin provision. Now, here's where you got to do it. You go into SCSI. Now we're going to scroll down to 10, and you can scroll down to whatever, but it can't be on the same reservation of 0. So you have reservation device. I'm going to go down to SCSI 10. And it's just going to say, you want SCSI 10. Yes. Now, what did it do? It added another SCSI controller. Okay, so what I'm going to do here is I'm actually going to select the VMware paravirtual. And you actually have some other options here. I think the bus logic parallel is for older virtual machines, but usually LSI Logic SAS or LSI Logic Parallel are pretty good. And again, you don't have to do this on all virtual machines, but it does help on some CPU cycles and faster access to data stores. So I've added it. It's adding it down here. And there we go. It picked it up. Nope. I don't think I clicked on it fast enough. There we go. So it says the VMware PV SCSI controller is ready to use. Awesome. And if you just wanted to add another disk, I'll just show you that real quick. So I got my server manager up already. If you don't know how to get there, just start, right-click on computer and manage. I don't really care. This can be MVR. I don't really, it's whatever. But I am just going to create a new symbol volume and next right through it. Defaults are fine. I just want to make sure that my new volume's coming up, and so I go to computer, and I can see I got my new volume there. Awesome. So now what I'm going to do is I'm going to shut down, say adding paravirtual adapter. So now it's shutting down. Alrighty. And we go to Edit Settings. I'm going to remove this hard disk, and a lot of people don't know this. You hit remove, it doesn't remove it. A lot of people just hit remove and OK. If you want to delete it from the data store, you got to hit remove and delete. I've seen a lot of people carry over old stuff. But, okay, so we got it installed. We saw the installation wizard complete. Now we're going to say we want to change this adapter type to paravirtual. We do this on our SCSI controller 0. And it's showing down here that it, move that over, is a replacement. And I'm going to show you one other quick thing. If I can hit it, yes, I want you to power it on. That's what comes up if you have it in manual mode. If I can get into the virtual BIOS. And I think I may have already disabled it, but I want to show you. Yeah. Basically in your virtual BIOS, you have, just like a normal computer hard drive BIOS, only here I have this thing called Advanced. And I can go down to I/O devices. Normally this would be populated. I always disable it because I want as few as devices that I have enabled, so the hypervisor doesn't have to go, okay, does this need to talk? Does this need to talk? Does this need to talk? I like tuning for performance. So I know it was already disabled. Exit. I'm gonna save changes. I didn't change anything, but either or. And we're going to see it boot up. Now, if you didn't do it this way, you're probably going to see a blue screen of death pop up here, but because I used the paravirtual, oh wow, that was fast. And this is on a 7200 RPM drive, so this is pretty good. Bam! I'm already in there. So there's a little bit of a performance increase. I'm using a little ZFS NAS, but that's a lot faster than what I've seen it. And this, it redetects this SCSI controller as on the main boot device, and you probably just want to go ahead and get that restart now out of the way. And yep. Avoid using additional I/O devices, like going into the BIOS, disabling the floppy controllers, serial ports, parallel ports. Another key thing, like when I was getting into that CPU ready time earlier, use one virtual CPU at all cost. Even if you're seeing utilization from 50 to 60%, that's okay. You have some overhead there. If you're seeing regular, I'm hitting 100% at when everybody comes in.
The organizer has ended the session, and this call will be disconnected.